In this video clip, we're going to talk about the polynomial functions. We'll see the graph of these kind of functions. What is a polynomial function? The general form of a polynomial function is like this. Is f of x equals a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus until a1 times x plus a sub 0. Where n is a non-negative integer. Okay, and the a sub n cannot be 0. Okay, here are the special cases. For example, n can be 0, then the polynomial will be what? Will be just f of x is a sub 0. Okay, so in this case, for example, f of x is 3. So y is 3, the function is a horizontal line. Well, n can be 1. Then the function f of x equals a sub 1 times x plus a sub 0. That's a linear function with slope a1. A1, based on a sub n is not 0, so a1 is a slope, no 0 slope. Okay, and n can be 2. Here is the special case, you see. That's for n equals 1. Is a linear function, the slope is negative 3. And n can be 2. If n is 2, the general form will be a quadratic function. And then the graph, for example, this special case will be the graph of 2 times x squared plus 3x minus 1. Okay, so when n is 2, the polynomial will be a quadratic function, and the graph of the function will be the parabola. Okay, all those 3 things we have seen before. So in this lecture, our major focus is based on the degree 3 or 4. By the way, for quadratic function, the degree is 2, based on this definition. n is called the degree of polynomial. So here n is 2 means degree is 2, is a parabola. n is 1 means the degree is 1. So then you have a linear function with no 0 slope. And n is 0 means it's a horizontal line. Okay. And then a sub n is called a leading coefficient. In this case, when n is 1, the leading coefficient is a1. In the special case here is negative 3 is the leading coefficient. For n equals 2, the leading coefficient is a2. In our example here, the leading coefficient is 2. Okay, And here we have a ak times x to the k, and ak is called a coefficient of this 10, ak times x to the k. So here, the coefficient of x is -3, is also a leading coefficient. And for quadratic function, and the a1 is the coefficient of x, a2 is the coefficient of x squared, and a2 is also the leading coefficient. In our example here, 3 is the coefficient of x, and 2 is also the coefficient of x squared. 2 is the leading coefficient, the highest degree, the coefficient of the highest degree will be the leading coefficient. Our major focus in this section is about the graph of a polynomial with degree equals 3 or 4. Like the one right here will be degree 3, because that's the product of 3 linear polynomial. So the degree here is 3 when you expand this polynomial. Okay, you'll get that. So we will see how we are going to draw this polynomial. And then before we do that, we have noticed that we have 0 points for what? For x equals -2, 1, 3. 1 here, x is x plus 2. You plug in -2 here. So the first factor will be 0, because -2 plus 2 is 0. The other two are not 0, but 0 number times no 0 number, you always get 0. So please be careful. When x plus 2 from here, you get 0 point is -2. For x minus 1, x minus 3, the 0 points is 1 and 3. You plug in 1 here, 1 here, 1 minus 1 is 0. Of course, the other two are not 0, but that does not matter, because the middle term you get 0. 0 times any number, you will get 0. So is the case for x minus 3. You plug in positive 3 here, you'll get 0 for the whole polynomial. That means what? That means basically this is the case. Okay? You have a -2, 0, which is on the graph right here. Okay? This point. Alright? And you also 1, 0, because you plug in 1 here, you get 0. And you have a 3, 0 here. Okay? You plug in 3, you get 0. So 3, 0. So you already know there are 3 points on the polynomial graph of this one. Okay? Then you may want to do is to find no 0 points. Okay? No 0 points. You may consider that the first no 0 point is the 3.1. Where is 3.1? X is 3.1 means x is greater than 3. Greater than 3. So you see, you plug in 3.1 here, you can look at plug in 3.1 into the polynomial. What can you see? That's the one right here. Okay. So you plug in 3.1, you have a 3.1 minus 3 is positive because, you know, 3 minus x minus 3, you plug in a number here, which is greater than 3, of course, you get positive. Yeah, 3.1 is on the right-hand side of 3. Okay, so is the case for what? For x minus 1. You plug in 3.1 here, minus 1. So 3.1 minus 1 is also greater than 0. Of course, for the first factor is 3.1 plus 2. You get all positives. So for the 3.1, you get all positives. And then the value is 1.071. Okay, you'll have this point, 3.1 and 1.071 is on the graph. Okay, similarly, you can choose 2, which is between these two 0 points. Okay, so you will have this expression. Because 2 is less than 3, you will get the third factor is -1, negative. The other two factors, you'll get positive. Okay, because this 2 is greater than 1 and is also greater than -2. You see the actual calculation is right here. Okay, so you get 1 negative from here. 2 minus 3 is -1. All right, and you got 2 positives, so you got -4. So 2 -4 is somewhere 2, and -4 is below it. Okay, so you do this for -1 and f of -2.1 yourself. -1 is this point. That's between those two 0 points. Okay, and then -2.1 is the point on the left-hand side of the first 0 point. All right, so then you have how many points? 1, 2, 3, 0 points plus 1, 2, 3, 4 points. Because these 3 0 points divide the whole axis into 4 parts. And then from each interval, you choose a point. 3.1 is last point to the right. 2 is between those two 0 points. -1 is between those two 0 points. Okay. -1 is between these two 0 points. Okay, and the -2.1 is the point on the left. So you get 7 points. Okay, you may click on here to see the no 0 points. All right, those that no 0 points. Let me eliminate the 0 points. So you have 1, 2, 3, 4, 1, 2, 3, 4, no 0 points. Why do we need this point, 0, 6? Where is this point from? You have to mark y-axis. So y-intercept. You plug in 0 here. You plug in 0 here, what do you get? you see, let me do the calculation here. I want to move this one slightly into here. So you see, you plug in 0 plus 2, and then 0 minus 1, 0 minus 3. What do you get? You have a 0 times negative 1 times negative 3. Is that 6? So then, 0, 6. X is 0. Y is 6. So this point is also on the graph. You have so many points now. You can now connect all the points by a smooth curve. This is the y-intercept. So you may mark the 0 points and no 0 points all together. You can then have the curve is like this. Okay, you use a smooth curve to connect all the points. You will have the graph. All right? Yeah, please review this lecture. I'll see you next time.